There are 15 girls and some boys among the graduating students in a class. They're planning to get together, which can be either a 1-day event or a 2-day event or a 3-day event. And so, girls and boys, 15 of them, some X of them, 1 day, 2 day, 3 day. There are 6 singers in the class, 4 of them are boys. There are 10 dancers in the class, 4 of them are girls. So singers, 4 boys and 2 girls. Dancers, there are 6 boys and 4 girls. Nice. Boys and girls we don't know. Singers, there are 4 boys and 2 girls. Dancers, there are 6 and 4. We don't know how many boys are there totally. We just captured the data, nothing more. There are many more layers to this. Let's attack this. Some students are not interested in attending the get together. Those students who are interested in attending a 3-day event are also interested in attending a 2-day event. Those who are interested in attending a 2-day event are also interested in a 1-day event. So 3-day event, 3-day event, 2-day event, 1-day event, and then there are people outside of this. This is a subset of this, a subset of this. 3-day, 2-day, 1-day, and outside. There are some number of people here as well. So this is like a Venn diagram, a nested subset thing. Right? So, and there are going to be boys and girls in each of them. And then this complicated singer dancer thing is also going to come. And already I'm not that comfortable because there is one hierarchy which is 3-day, 2-day, 1-day, and none at all. And there is boys and girls. And then there is singer dancer somewhere in the equation. Right? So we don't even know how many boys are there totally. Right? Interested in 3-day events, 2-day events, 1-day event. I originally drawn circles and it didn't work out well. Raghu had the idea of doing it like this. It looks much better. Right? So thanks, Raghu. Super. And then we come to other conditions. So we layer it on and say for each of this 3-day, 2-day, 1-day, we could have dancers and singers, neither dancer nor singer. So we have layers of classifications. Some of these will probably never get the detail, some we may. Let's see where it goes. And now let's go to the conditions. All the girls and 80% of the boys are interested in attending a 1-day event. All the girls and 80% of the boys. That is 20% of the boys, which is 0.2x, is outside. This is 0.8x. This is all boys. Number of girls, 0. Who are not interested in attending is 0. All the girls are interested, so this outermost should be 15 totally. Singers, dancers, neither, all put together. This is 0.2x. We're talking about integers. So this is 1 by 5x. 1 by 5x should be an integer, or x should be a multiple of 5. And so it could be 5 and 1 or 10 and 2. Obviously there are at least 10 boys. So we're talking about 10, 15, 20, 25, 30, one of those numbers. X is a multiple of 5, because there's a 0.2x involved here. Nice, let's go to the next condition. Some of the girls are interested in attending a 1-day event, but not a 2-day event. So there are some number here for girls, not here, but here. 1 day, but not a 2-day event. Some of the other girls are interested in attending both. That is, some numbers come here or here, both 1 day and 2 day. So inside 2 day there are a bunch of numbers, not 0. This is not 0 either. Outside is 0 for girls, that much we know. 70% of the boys who are interested in attending a 2-day event are neither singers nor dancers. So we're interested in attending a 2-day event. Of the boys, 0.2x goes away here, 0.2x goes away here. So we have 0.6x remaining for 2-day event. 70% of them are neither singers nor dancers. 30% of them are singers / dancers. So if you think about singers / dancers, if you think about this whole region, singers and dancers, boys, that should be 0.18x. 30% of 0.6x. 70% are neither dancers nor singers. That means the remaining are dancers or singers. We already know that singers and dancers, there's no overlap. That's very clear, been given. 60% of the girls who are interested in attending a 2-day event are neither singers nor dancers. So 2-day event, 40% of them would be singers or dancers. 40% would be singers or dancers. So this singer and dancer put together is 40% of the total number. 40% is 2 by 5. The total number for the 2-day event should be a multiple of 5. Total number of girls should be a multiple of 5. And this number here, all put together, singer and dancer, is 40% of something. So it should be a multiple of 2. This is 0.18x. 0.18 is 18 by 100. Or 9 by 50 of x. 9 by 50, that means x should be a multiple of 50. Otherwise, this won't be an integer. If x were 50, this will be 9. If x were 100, this will be 18. We know the total singers and dancers is just 10. So x cannot be 100, x has to be 50. That's brilliant. The total number has to be 50. That means this is 10 here, this is 10 here, this number is 9. Singer and dancer put together for 2-day event, which includes the 3-day event, is 9. Singer dancer put together. Brilliant. 60% of the girls who are interested in attending a 2-day event are neither singers nor dancers. That we'll probably use a little later. 40% are singers or dancers. Now we know that this is 9, this is 10, this is 10. The total number of boys is 50. That much more. No girl is interested in attending a 3-day event. 3-day event is 0, 0, 0. Brilliant. That means there should be quite a few number here within the 2-day event, that region. 2-day but not 3-day, there should be some number. All male singers and 2 of the dancers are interested in attending a 3-day event. All male singers. How many male singers are there? 4 male singers are there. So let's draw a line here. Make this 4. And 2 of the dancers. 2 of the dancers. Dancers have to be male because female is 0. 2 of the dancers are here. Brilliant. So overall there is 9. All male singers are taken. Overall 9. So that means if I extend this, this should be 0. That all male singers are sitting here, the 3-day event. Only 2-day but not 3-day, that should be 0. This is 4, this is 2. 4 and 2. So I'm taking off this 9 and putting 3 here. Brilliant. So male singers should be 0 and 4. Only 2-day, 3-day also. And 3 and 2. Only 2-day, 3-day also. Brilliant. And this is 0, 0, 0. How many girl singers are there? 2 girl singers are there and 4 girl dancers are there. She'll have to figure that out. The number of singers interested in attending a 2-day event is 1 more than the number of dancers interested in attending a 2-day event. Singers in a 2-day event, singers would be 4 so far. Dancers would be 5. Number of singers is 1 more than the number of dancers. This is 5, singers should be 6. This is 6, singers should be 7, and so on. And so the 2-day event, the 5 dancers already included from boys. See, the number of singers interested in attending a 2-day event is 1 more than the number of dancers. So dancers is 5. Singers could be 1 more than that. It could be 6. Means this could be 2. This could be 0. That's a possibility. Or we could have more than 2 singers with dancers also coming in there. But we have only a maximum of 2 girl singers. We have only 6 singers with us. We already have 5 dancers. So the number of singers has to be 6. So this should be 2. Which means this should be 0. Nice. Lovely. So we filled this out rather well. Let's continue with this. 60% of the girls who are interested in attending a 2-day event are neither singers nor dancers. Singers or dancers is only 2. That is 40% of the total people who are interested in doing a 2-day event. That means if this is 2, this has to be 3. Totally 5. 40% here, 60% here. Neither singer nor dancer should be 3. The 4 dancers among girls. There is no girl that is outside, that we know. So all 4 dancer girls should be in this region, not this. This is 0. So 2 plus 4, 6 plus 3, 9. Everything is filled. So this should be the remaining 6. That also we can fill. 15 girls are there totally. Now we fill the entire grid. Very interesting question, but properly challenging. I struggled and struggled and struggled for this because there are classifications between boys and girls. And there is day 1, day 2, day 3 nested subset structure. And then singers and dancers for boys, singers and dancers for girls. Given that we grab onto this way of presenting data and then simplify and do it methodically, it seems easy, but a properly challenging, tough question. Let's attack the question now. This how many boys are there in the class is easy, 50. It should be a multiple of 50, 100 doesn't work, 50 works, done. Which of the following can be determined from the given information? The number of boys who are interested in attending a one-day event and neither dancers nor singers. One-day event, neither dancers nor singers. Let's see this. So how many? 5 dancers are already taken. There's 1 dancer remaining. 4 singers are already taken among boys, but there's 1 dancer still remaining. That could be here or here. So I don't know where that missing dancer is. Is he the person who wants to attend a one-day event but not 2-day or 3-day, or who does not want to attend any of this, quite happy sitting outside? We do not know that yet. So statement 1 cannot be handled. We cannot answer this question. So if we have 1 missing dancer, that person could be here or here, right? The totally 6 boy dancers, 5 we have accounted for, 1 still missing, therefore we cannot answer that. The number of female dancers who are interested in attending a one-day event. Female dancers, one-day event, of course, that can be answered. 2 can be answered, 1 cannot be answered, only 2. What fraction of the class are interested in attending a 2-day event? 2-day event is this circle. So this 10 goes off, that 10 goes off, 10 plus 10, 20 is gone, this 10 is gone, 30 is gone. So the remaining, totally there are 50 plus 15, 65 people, 50 boys and 15 girls, 65 people, of which this 10 is out, this 10 is out, and this 10 is out, 30 is out. 35 are interested in attending a 2-day event, which includes a part which is interested in attending a 3-day event also. So 35 by 65 are interested. So 2 plus 3, 5 plus 4, 9 plus 2, 11 plus 3, 14 plus numbers here that need to come in. So remaining is 35, 35 by 65, 7 by 13, done. What best can be concluded about the number of male dancers who are interested in attending a one-day event? Male dancers 5 are there for sure. 6th one, that missing one, could be here or could be outside. The number of dancers who are interested in attending a one-day event but not a 2-day event, that sliver, could be 0 or 1, or the total could be 5 or 6. We cannot say for sure that it has to be 5 or it has to be 6. 5 or 6, both are possible. How many female dancers are interested in attending a 2-day event? 2-day event, this, including this, female dancers, 0, 0 for sure. We know that's 0, 0 for sure, 0, done. 3-day event and 2-day event. 2-day only, 2-day but not 3-day and 3-day. This whole thing is 0, 0, 0, 0 totally. Lovely set, super challenging, even though the solution kind of looks doable, super tough in an exam context. A specialty supermarket sells 320 products. Each of these products was either a cosmetic product or a nutrition product. Either cosmetic or nutrition. Each of these products was also either a foreign product or a domestic product. When 2 types of classifications come, I start getting tired. Each of these products had at least one of the 2 approvals, FDA or EU. 3 types of classification. Foreign or domestic, cosmetic or nutrition. Thankfully, there's no overlap between cosmetic and nutrition, no overlap between foreign and domestic. But there is an overlap between approval with FDA or EU. You could have FDA approval alone, you could have EU approval alone, you could have both approvals. Right? Nice. So 320 products broken in three different ways. Right? I'm sure they're going to wind us up by saying nutrition products inside foreign, domestic products under cosmetic, all kinds of stuff. And so let's attack this. Let's have some fun. The following facts are also known. There were equal number of domestic and foreign products. Nice. So domestic and foreign is 160, 160. Half the domestic products were FDA approved cosmetic products. Domestic products, half of them were 160, half 80. 80 is FDA approved cosmetic products. None of the foreign products had both the approvals. So foreign products get into two parts. FDA approval or EU approval, not both. Only one or the other. Disjoint sets. There are 140 nutrition products. Half of them were foreign products. So out of the 140 nutrition products, half were foreign, half were domestic. There were 200 FDA approved products. 70 of them were foreign products. So 130 are domestic. 120 of them were cosmetic products. 80 of them were nutrition products. Between foreign and domestic, it's just two parts. Between cosmetic and nutrition, there are just two parts. Only this FDA and EU, we need to be careful. Right? Nice. Let's make sense of this. Domestic breaks into cosmetics and nutrition. Foreign breaks into cosmetics and nutrition. We're going to start off like that. The FDA and EU thing is going to be like this. We need to remember that. It's FDA approval, EU approval, and both. Right? Sitting there. 320 products, either a cosmetic or nutrition, either foreign or domestic. So we think about domestic or foreign. Under that cosmetic and nutrition, under that cosmetic and nutrition. We're going to say cosmetic and nutrition, domestic and foreign, domestic and foreign. Those two are completely fine. So equal number of domestic and foreign products, 160, 160. There are 140 nutrition products, half of them were foreign products. So this is 70, this is 70. Of nutrition products, out of 140, 70 were foreign, remaining 70 should have been domestic. I mean, this is 70, cosmetics will be 90, this cosmetics also 90. Nice, so far so good. Half of the domestic products were FDA approved cosmetic products. So, of this domestic, here we can say FDA approved and EU approved, right? Or both, it's also possible. So, I'm not going to say EU approved, FDA approved is 80, maybe EU only is 10. Remembering that within this FDA approved, there could be some chunk that is EU also. And so keeping that in mind, FDA is 80, EU only is 10, FDA and EU could still be there. Within this 90, that is still there. We don't know what that is. This is 80, this is 10, there is some overlap here. Outside is 0, every product has at least one of the two approvals. That much we know. There are 200. None of the foreign products had both approvals, while 60 domestic product had both the approvals. So the foreign side, FDA and EU are two separate things, no overlap. It's rather simple. So this is 90 and 70, 90 and 70, and within cosmetics there's FDA and EU, within nutrition there's FDA and EU, there's no overlap. Nice. Let's look at this. There are 200 FDA approved products. Nice. 70 of them were foreign products and 120 were cosmetic products. And so 120 were cosmetic products, which is nice. So of the 120 cosmetic, 80 are domestic. So 40 cosmetic products should be EU, should be foreign. This is 40, it should be 50. No overlap adding up to 90. Nice. 200 FDA approved products, 70 of them were foreign. Of the foreign, cosmetics are 40, so nutrition should be 30. This should be 30, this should be 40, adding up to that. So 30 and 40, 50 and 40. Wonderful, so far so good. 200 were FDA approved, 70 of them were foreign. So 130 were domestic, 80 are domestic cosmetic. Out of 130, so this should be 50. Nutrition is 70. EU only should be 20. You still don't know this number. You'll have to come back to it. Right. None of the foreign products had both approvals, while 60 domestic products had both approvals. Fine. So this FDA of 80 and FDA of 50 in this, within this 60 have both. So if you think of this both put together, cosmetic and nutrition, cosmetic would be 90 and 70, total 160. FDA adds up to 80 plus 50, 130. EU only is 30. This overlap is 60. This should be 70. But this is both cosmetic and nutrition put together. How many of FDA and EU together sit in cosmetic and nutrition? We don't know. We don't know as of now. Maybe something else will come. Right. How many foreign products were FDA approved cosmetic products? Foreign cosmetic FDA approved 40. Done. How many cosmetic products did not have FDA approval? Cosmetic products 90, 80 had FDA approval. These 10 did not have, because that is EU only. Cosmetics 90, 40 had, these 50 did not have. How many cosmetic products out of the 180, 60 did not have FDA approval? 10 plus 50, 60. Which among the following options best represent the number of domestic cosmetic products that had both the approvals? Domestic cosmetic that had both approvals. So it could have been, 10 had only this, 80 had FDA. So if we do look at the diagram, then FDA is 80, EU only is 10, 80 plus 10 adds up to 90. The overlap in between could have been 60. How many had both approvals? Best represents the number of domestic cosmetic products that had both approvals. We should have been looking at within what is the maximum both of these could have been there. Right? So this could be 60, all 60 could be here. This could be 20, 20, 60, 10 adding up to 90. You don't find anything wrong with that. It cannot be more than 60. It simply cannot be more than 60. So these two are ruled out. Only 60 had both approvals. EU and FDA approvals, maximum of 60 were there. Right? So at least 10 and at most 60, at least 20 and at most 50. Think about at most 50 and 10 here. There are 10 that had only EU, 80 had FDA. It would be a maximum of 60, at least 10 and at most 60, at least 20 and at most 50. No, at least 10 here, at most 50, because meaning that there had to be some overlap here also. 80 plus 50 is 130, 130 plus 70 is 200. Yeah, that works. Yeah, going for at least 10 and at most 60. Maximum is 60, at least 10, at most 60. If 70 cosmetic products did not have EU approval, 70 cosmetic products did not have EU approval. So 70 cosmetic did not have EU approval. Okay, out of 70 totally, these 40 do not have EU approval. Right. So another 30 do not have EU approval. So that 30 should have been from here. 30 did not have EU approval. That means 50 should have had EU approval. So this, looking at cosmetic, domestic, EU and FDA. EU is 10, FDA FDA but not EU. 40 go away here. This should be 30. It should be 50 here. So 50 cosmetic products under domestic had EU and FDA approvals, both of them. And so 10, 50, 30, that's when this 30 and that 40 will add up to 70 without EU approvals. That means of the 60 that had both approvals, 50 have domestic, 60 are cosmetic domestic, 10 are nutrition and domestic. So how many nutrition products had both approvals? None here, 10 here, 10. It's a beautiful question based on the intersection part. 50 nutrition products did not have EU approval. 50 did not have EU approval. Of the nutrition product, these 30 do not have nutrition. So that is 30. Another 20 did not have EU approval. That 20 should come from here. So if you look at this diagram, EU only is 20. FDA only should be another 20. That means 30 here, 20, 30, 20, adding up to this 70. That means of the 60 overlap, 30 is happening here, another 30 is happening here. How many domestic cosmetic products did not have EU approval? Out of this 80, 30 are common, remaining 50 did not have. Answer is 50. Out of this intersection of 60, 30 is sitting here, another 30 should sit here. Both approvals is 60, both under nutrition is 60, both under cosmetic should be 60. Both under cosmetic is, both under cosmetic should be 30. This 30 goes away. Remaining 50 have only FDA approval, no EU approval. That's what we're looking at. Answer is 50. Lovely. I'm going to go to the next set. This is also a very interesting set. Let's see if we can grab this and complete this off. Musical instruments. 10 musicians A, B, C, D, E, F, G, H, I, and J are experts in at least one of the following 3 percussion instruments: tabla, mridangam, and ghatam. Nice. Among them, 3 are experts in tabla but not in mridangam or ghatam. Lovely. Tabla only. I like this only things. Very easy. Another 3 are experts in mridangam but not in tabla or ghatam. 3 here, 3 here. They put 3 more in the third one, I'll be thrilled. And 1 is an expert in ghatam but not in tabla or mridangam. Just when I thought we were on a roll. Further, 2 are experts in tabla and mridangam but not in ghatam. 1 is an expert in tabla and ghatam but not in mridangam. I think we've accounted for 3, 3, 1, 2, 1. 3, 3, 1, 7, 9, 10. We've accounted for the 10 in these categories. That means there's nobody who's an expert in all 3. We have mapped it on, put it wonderfully inside. So the following facts are known about these 10 musicians. A and B are experts in mridangam, but only one of them is also an expert in tabla. D is an expert in both tabla and ghatam. F and G are experts in tabla, but only one of them is an expert in mridangam also. A and B, mridangam, and one of them in tabla. F and G, tabla, one of them in mridangam. Neither I nor J is an expert in tabla. Neither H nor I is an expert in mridangam, but one of them is an expert in ghatam. Obviously, I cannot remember all of these. And so I'm going to put the numbers in first. This is like a classic Venn diagram set. Only instead of just dealing with numbers and A intersection B, the number of people, elements in that, we're going to put elements inside them. So let's first put the numbers part, then we'll go to the elements part. And so tabla, mridangam, ghatam. There are, among them, 3 are experts in tabla, but not in mridangam or ghatam. So this is 3. Another 3 are experts in mridangam, but not in tabla or ghatam. There's some autocorrect that's happening there. And 1 is an expert in ghatam, but not in tabla. Lovely. Further, 2 are experts in tabla and mridangam, but not in ghatam. That is this number, 2. And 1 is an expert in tabla and ghatam, but not in mridangam. This is 1. So 3, 2, 3, adding up to 8, 9, 10. This should be 0. This should be 0. We've got the numbers all in place. Brilliant. I'm going to put the numbers in place. 3, 2, 3, 1, 0, 0, 1. Now we have to keep the second set of constraints in mind with the people, names and all that. Let's see. D is an expert in both tabla and ghatam. Tabla and ghatam, there's only one guy who's an expert. This is D. Done. Now, the other thing that was interesting, A and B are in mridangam, but only one of them is also an expert in tabla. F and G are expert in tabla, but only one of them is also an expert in mridangam. So these two we've accounted for. A or B F or G. The other one of the A and B are experts in Mridangam. So A/B goes here. G/F goes here. One of these two comes here, the other comes here. So it could be BF, AG, AF, BG, anything sitting here. The other will be here, the other will be here. Right? Neither I nor J is an expert in tabla. Neither H nor I is an expert in Mridangam. I really like one thing. I can trap I. I is not an expert in tabla. I is not an expert in Mridangam. I is not is wrong English. Should be I am not. Which is also true. I am not an expert in any of these. And so neither H nor I is an expert in Mridangam. Neither I nor J is an expert in tabla. So I is not on this list. Is not on this list. Or this one should be I. We've got D in the bag. We've got I in the bag completely. And one of AB or FG has to be here. Other of AB goes here. The other of FG goes here. And so let's fill this in. And then we'll build. One of A or B falls here. One of F or G falls here. The other of A and B goes here. The other in F and G goes here. Right? Lovely. Now build on this. Neither H nor I is an expert in Mridangam. So neither I nor J is an expert in tabla. I is here. J is not an expert in tabla. So J should not be here or J should be here. H or I is not an expert in Mridangam. H is not here. H should be here. So this 3, I'm going to write it as H plus 2. This 3, I'm going to write it as J plus 2. Fine. We need to remember that even in this 2, we know one of these two is F or G. We know one of these two is A or B. We've accounted for A, B, F, G. 2 here. One among A, B, one among FG, the other here, the other here. We've accounted for D, I, J, H. And so, think about this. I'm going to write everything down. A, B, C, D, E, F, G, H, I, J. A, B, F, G. One of the two here, the other here. One of the two here, the other here. These 4 are accounted for. H is in the bag. I is in the bag. D is in the bag, J is in the bag. We need to figure out something about C and D. We don't really know much, nothing has been given. But we know that H plus 2 are here, J plus 2 are here. One of these two is F or G. One of these two is A or B. The other should be C or E. This is C/E. One of these is E/C. Lovely. So I'm going to So we've had everything. T intersection M has one of A and B and one of F and G. A/B and F/G. T only has F/G. I'm going to write it as G/F. That is F/G. This is the other one. C/E and H. M only has B/A. The other one comes here. E/C and J. T intersection M has one of A and B, one of F and G. We cannot really go beyond this. Fine. So hopefully the choices and questions will be interesting, simpler, based on just this set of inferences we have made. Fine. Let's jump in. Who among the following is definitely an expert in tabla, but not in either mridangam or ghatam? Tabla only. Only thing we know in tabla only is H plus 2 others. A need not feature here. A is here or here. F need not be here. H has to be here. C need not be here. So the only one we can be sure of is H. Who among the following is definitely an expert in mridangam, but not in either tabla or ghatam? J. J plus 2 others. We've got that. We've got that in the bag. So J is definitely an expert in mridangam. The 2 others could be one of A or B, and then one of E or C, all that we can do. But J is definitely in. I keep forgetting with this A or B. Yeah, A or B. Lovely. Which of the following pairs cannot have any musician who is an expert in both tabla and mridangam, but not ghatam? Tabla, it should not table and mridangam. Tabla and mridangam, but not ghatam. This one. So it is one of A or B and one of F or G. It could be AG, BF, AF, BG, any of that. It cannot be A and B. This is the answer. It could be F and G. Okay, which of the following pairs cannot have any musician who is an expert in both tabla and mridangam but not in ghatam? So A, B, F, G. So A and B, A is there. So this could be a possibility. F and G both are there. C and D, this is the answer we're looking for. C and E both cannot sit here. One of C or E sits here, the other sits here. So the question says, tell me the two that cannot be in T intersection M but not G. Cannot be. A can be, B can be, F can be, G can be. C cannot be, but F could be. C and E cannot be. That's the answer we are looking for. If C is an expert in mridangam and F is not, C is an expert in mridangam, that means this should be C, that means this should be E, E should go here. T only has F and G, C and E and H. M only has A slash B, E slash E. C is an expert in mridangam and F is not. F is not an expert in mridangam. That means T only has F or G. That means F is not here. This should be F. This should be G. Of F or G, one has to be here, the other has to be here. F is not here. C is an expert in mridangam and F is not. That means F should be here, G should be here, C should be there. Then which are the three musicians who are experts in tabla but not in either mridangam or ghatam? Tabla but not in mridangam or ghatam. This tabla only. E, F and H. E, F and H. Got that. And so if C sits here, that means E should sit here. F is not here. We told F is not an expert in mridangam. That means F or G is here. F cannot be here. F has to be here and G has to be here. Or in tabla only, we need to have A, F and H. This is what we are looking for. Treatment. 1,000 patients currently suffering from a disease were selected to study the effectiveness of treatment of 4 types, A, B, C and D. Very topical, very relevant now. These patients were first randomly assigned into 2 groups of equal size, so 500 each, called treatment group and control group. This is how it's typically done. The patients in the control group were not treated with any of these medicines. Instead, they were given a dummy medicine called a placebo, right, containing only sugar and starch. The following information is known about the patients in the treatment group. A total of 250 patients were assigned with type A medicine and a total of 210 were treated with type C medicine. The moment I read this, I know that type A, type C, these two, they just add these numbers, it's 460. That means it looks like we're going to have a bunch of people who have been given A and C, B and C, A, B, C, B, C, D, etc., etc. There's not a total adding up to 500 with 4 groups. Right? So, which means you're looking at set theory. When there is an A intersection B, B intersection C, all of that is going to be there. Right? 25 patients were treated with type A medicine only, 20 were treated with type C medicine only, 10 were treated with type D medicine only. A only, C only, D only. Right? Let's go on. 35 were given A and D only, 20 were given A and B only, 30 were given A and C only, 20 were given C and D only. 100 were treated with exactly 3 types of medicines. I'm not going to register all of this because chances are I can't retain all these numbers. We're talking about A intersection B only, A intersection B intersection C only, A, B only, B, C only, etc., etc., etc. So I'm going to go revert to the Venn diagram, the standard format of dealing with this, then fill all the data in. And so it's a beautiful representation of 4 sets Venn diagram. Set A, set B, set C, set D. And then this part is A intersection B only. This is B only, A only. Each of these regions that I've marked are those regions only. Keep that in mind. So this is A only, A and B only, B only, C only, C and D only, D only, and so on. So suppose you wanted to find A intersection B, that will include all of this. A and B only, A, B and C only, A, B and D only, A, B, C and D. Each of these regions, remember, This region does not represent A intersection B intersection C. It represents A intersection B intersection C only. Keep that in mind. So we have 3, 6, 9, 12, 15 regions defined. None of these will be outside. That's not our scenario. Overall 500 have to be accounted for here. So with this diagram, it becomes very easy to fill in the data. And it becomes very tough, annoyingly tough to intuitively track 4 sets. And so it is best to plug in whatever you have and then go for the figuring out part. Right now, I can't register all the data. Look at this, there are 15 data points. Right? And then you could be given total of A, total of C, total of B as well. It's impossibly tough to retain all of that and then have some sense of intuition with it. Plug in a few numbers, see where that takes us, then come back and figure out whatever we need to figure out. Right? A total of 250 were treated with type A medicine, so this should be 250. And 210 with type C, this is 210. Lovely. 25 were treated with type A only, so this is 25. 20 were treated with type C only, so this is 20. And 10 were treated with type D only, this is 10. I'm going to fill in whatever I can based on the data, then we'll figure out the rest. Right? I fill these in, and then 35 were treated with A and D only, A, D only, this should be 35. Lovely. 20 patients were treated with A and B only, so this is 20. 30 were treated with A and C only, 30 here, lovely. 20 were treated with C and D only, this is 20. Once again, lovely, so we're filling quite a few. 40 were treated with types of medicines A, B and C, but not of type D. A, B, C, but not D. This is 40. Lovely. 20 were treated with A, C and D, but not B. A, C and D, but not B. This is 20. Lovely. So you're filling quite a few. So you fill quite a lot of data points. Let's go ahead. 50 were given all 4 types of medicines. 50. And so we filled quite a few. So this is 250, this is 210. We filled, this is not 10, but we filled almost everything here. Then there are only about 1, 2, 3, 4, 5 that are remaining. Even in this 5, we know the total is 500. So if we get 4, we can get the 5th one. Is there any other inference we can make? C total is 210. If we get, no, there are big gaps in C, 2 gaps in C. A total is 250. Yeah, we can get this. We have this, we can get this. And so we can make those inferences. A adds up to 250. What can we find from here? We can find ABD. How do you do that? 25 plus 35. These two add up to 60. I like to club the 5 terms together. 60, 80, 120, 150, 170, 220. 220 overall, so this number should be 30. And just checking this, 30, 50, 80, 100, 130, 170, 190, 190 plus 60, 250. Lovely. So we can find this, we have to fill that in. Let's go further. 100 patients were treated with exactly 3 types of medicines. Exactly 3 types of medicines would be A, C and D only, A, B and C only, B, C, D and D, A, B, D only. 20 plus 40, 60 plus 30, 90. This should be 10. 75 were treated with exactly 1 type of medicine. 75, exactly 1. This we know. 20 plus 10, 30. 30 plus 25 is 55. 75 totally, or B should be 20. With only 1 type, so 25 plus 20, 45, plus 20, 65, plus 10, 75. That also adds up. So we need to get BC and BD. And let's see if we can get both of them. And C adds up to 210. C is this chunk. That should add up to 210. 30 plus 20, 50, 100, 140, 150, 170, 190. So all these add up to 190. So 30, 50, 100, 140, 150, 170, 190. Or this should be 20. Lovely. So we've got everything here. almost everything that we need. So these 3 are filled, these 3 are filled, these 3 are filled, these 3 are filled, these 2 are filled, only this is missing. How do we find that? Overall, everything put together adds up to 500. Do the math and then get good. Everything put together is 500. A totally adds up to 250. Keep that in the bag. So the remaining should add up to 250. Good. 20 plus 20, 40. 40 plus 20, 60. 80, 90, 100. These all add up to 100, or BD should be 150. To add everything up, we know that A is 250. The remaining should be 250. Remaining not including A. Add everything up, it adds up to 100. This should be 150. So it's unusual. So when I came to this point, I was very surprised. I said all numbers are 10, 20, 30, 40, 25, 35. And then suddenly there's the 150. So I did a double take, but it turns out it is indeed 150. So this number should be 150. Lovely. Now we've got everything filled in. Now all we've got to do is answer the questions. Fine. How many patients were treated with medicine type B? Let us add everything up here. 20 plus 20, 40, 80, 100, 150, 160, 160, 190, 340. This alone is 150, 150, 200, 250, 300, 340. Just clubbing in hundreds and 50s. 340. Done. The number of patients who were treated with medicine types B, C, D, but not A. B, C, D, but not A. This number 10. Done. Very routine question. Once you've got the grid, you're just plugging in the answers. How many patients were treated with medicine types B and D only? B and D only. This is the anomalous looking number. The number that is a little off. Everything else is in a reasonable range. This is out of whack, off the charts. But once you've got the answer, maybe do a double take. But you've got to have the confidence to plug ahead. That is 150. The number of patients who were treated with medicine type D. D, that means we're adding all of this. I'm going to leave this 35 separately, add the rest. 20, 50, 30, this adds up to 100. 100 plus 150, 250. 260, 270, 290, 290 plus 35, 325. I don't want to deal with the 5 part, I'm dealing with that later. 30, 40, 190, 220, 270, 290, 325. I'm going to be doing a question from LRDI. This was from CAT 2020 slot 3. Wonderful question. And so, a survey of 600 schools in India was conducted to gather information about their online teaching learning process, OTLP, quite appropriate for this year. The following 4 facilities were studied. F1 owned software for OTLP, F2 trained teachers for OTLP, F3 training materials for OTLP, F4 all students having laptops. 4 categories. The following observations were summarized from the survey. 80 schools did not have any of the 4 facilities. 40 had all 4. Okay. Straight away, the important thing is to look at an LRDI set and then say where are the cards falling. This one, you read till here. I'm going to shift to my marker mode. Sorry. You read till here. Then you should be able to say, okay, Venn diagram, set theory. I'm drawing diagrams, I'm going to figure out. And so we have in none of the 4, we have all of the 4. We're going to treat F1, F2, F3, F4 as sets. We're going to talk about F1 union, F2 union, F3 union, F4, whole complement. That is this. All 4 intersection, that is this. Quite obviously then, after this, we'll move on to F1 and F2 only, F2 and F3 only, F1, F2, F4, all of those in some form. That's what I expect. It's very important for you to be able to pick a set. And this one is a Venn diagram set with 4 sets, F1, F2, F3 and F4. And I used to draw this nice circle diagrams, and it's confusing. So I tried that, and it took me a long time, and I was peeved. So one of the guys told me quite that was one very other interesting way of presenting data, and I kind of took to it. It's a very interesting way. I'm going to outline that. The number of schools with only F1, only F2, only F3, and only F4 was 25, 30, 26, and 20 respectively. But lots of data, lots of numbers. Even at this point, you can sense that you've got to draw a diagram and put that in, because beyond this, you can't retain. 80 outside, 40 in the middle, then 4 onlys. Yeah, okay, I can grab it. But now I suspect we're going to go into territory of F1, F2, and F3, F2 and F4, but not the other 2. And that becomes tricky to try to remember, but this is a Venn diagram question, right? So let's see the subsequent set of constraints, just glance through it, but not really take it taken too seriously. The number of schools with exactly 3 of the facilities was the same irrespective of which 3 were considered. This is interesting. 1, 2 and 3, 1, 2 and 4, 1, 3 and 4, 2, 3 and 4. All 4 numbers are equal. And 313 schools had F2. Again, is interesting. We've been given the F2 total number. 26 had only F2 and F3, but not F3 or F1 or F4. Among the schools having F4, 24 had only F3 and 45 had only F2. So 2 and 3 alone, 4 and 3 alone, 4 and 2 alone. Some nuggets were being given. 162 schools had both F1 and F2. Now, this number is not F1 and F2 alone. It's F1 and F2, F1, F2, F3, F1, F2, F4, F1, F2, F3, F4. All of those coming under this. The number of schools having F1 was the same as number of schools having F4. I'm not going to process all of this, but I have a sense. This is giving us 4 numbers. This is one large number of F2 and then assorted bits and pieces. I want to capture this data. It's nice, interesting format. So this is F1 under this rectangle plus square. This is F2. This is F3. This is F4. And interestingly, this format is very interesting because it helps us grab F1 as this entire set. The intersection between F1 and F2 is this. The 2 triangles meet. That jumps out. So entire thing is F1 and F2. If you take about this set, it is F1 and 2 and F3 or F1, 2, 3. This one is F1, 2 and 4, F1, 2, 4. Now, one distinction, when we say F1, 2 here, we mean F1 and F2 only. If you're thinking about F1 intersection F2, there will be this, this and this. Keep that in mind. When you're drawing this diagram, it's like our Venn diagram with 3 sets. So, this is not intersection of F1 and 2. It is F1 and F2 only. This is F1, 2 and 3 only, no F4. So the regions are nice and clear and self-evident. So this number is intersection of everything. Outside this whole framework would be none of these, the schools which have none of these facilities. And so out of the 600, some 80 are sitting outside. Each of these regions numbers can then be populated, filled in. And then we can try to simplify this. Now, this is the framework you're using. But remember, when I'm talking about this region as F1, 3, 4, which I've underlined it, that is F1, 3 and 4 only, no 2 in it. And so, whereas this number F1 is all of F1. This is F1 only. And so, if we look at it, we have, the question has already given us this number, this number, this number, this number. It has given us this number. It has given us the number outside. It has also told us that 1, 3, 4, 1, 2, 3, 2, 3, 4, 1, 2, 4 are all equal. And then in assorted fashion, it has given us some of the other numbers. And so a bunch of numbers we already know. Let's put them in and then we'll process it further. Fine. So total number, 80 did not have any of the 4. So the total number is 520 that we know. 40 had all 4. F1 only, F2 only, F3 only, F4 only at 25, 30, 26, 20. These numbers we have filled in. These we know. F2 totally is 313. That is something to keep in mind. So we might probably add all of this up, equated to 313. Right? We know something more than that. Let's fill that as well. We know that each of these numbers is equal. So I'm putting it as n. N, 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 n. And this is 40. 25, 30, 26 and 20 get filled in. This 313 is got filled in. Right? Just 26 schools had F2 and F3, but neither of the other two. This is 26. Right? Lovely. Right? So we know that 162 is the total F1 intersection F2. And so this, these 4 add up to 162. F1, 2, and then these add up to 162. Think about it. This is 40. These two are n and n. So 40 plus 2n is accounted for. So out of 162, 40 plus 2n, plus 2n is accounted for. Or we have 122 minus 2n sitting here. So F12, that is only 1 and 2, intersection of 1 and 2 without the other 2 is 122 minus 2n. And so now this helps us capture that 162 had both of them, right? The number of schools having F1 was the same as number of schools having F4. So if this is K, this is also K. My gut feel now is our most interesting starting point would be this 313. But let's fill this data point as out of people having F4, 24 had only F3. So F3, 4 is 24. That is this number. And 45 had only F2. F4, 2, 4. Yeah. Fine. So in this grid, these 4 have filled themselves. This is taken care of itself. These 4 have filled. We have this number, and this number already filled. We need to find F13, F14, and then if we find N, that will be a big breakthrough, because if we find N, then these 4 and this automatically get filled. And so our starting point now looks like it's going to be to find N. We know F2 is 313. In F2, we know this, and everything else is in terms of N. So if we attack that F2 being 313, maybe we'll get N, and that will take us somewhere. So let's jump that. So F2 is 313. That is, you add this 30, 26, 45, 40, and then the other expressions have N in them. So I'm going to add this. 30 plus 26 is 56. 56 plus 85. So this is 11, 141. To this we add 122 minus 2n, n. So 122 plus n. So to this we add 122 and then an n at the end. So we add this 263 plus n equal to 313, or this gives us n is 50. So using the idea that F2 is 313, we can plug in anything else. You could have slightly done the slight variant. F12 intersection is 162. So you could have said all of these add up to 162. We used that to even plug in 122 minus 2n. This whole thing adds up to 162. And then we have these 3 numbers we can find n. Either way is fine. So this is, we have plugged everything in, going cell by cell, or saying that, okay, this is 162. Let me worry about the remaining regions. I find n. Once you find n, 50, 50, 50, 50 fills itself. 122 minus 2n is 122 minus 100, 22. That takes care of itself. So a bunch of cells get filled. Now what are we going to do? We're going to attack the next nugget that we have not used, which is F1 is K and F4 is also K. And so F1 and F4 are both K. So add everything up, and then equate the two. We should find something that is missing from this nugget. One way of doing that is to do that. I'm going to do a slight variation. I'm saying this is F1, this is F4. So this chunk is present in both of these lists. And so F134, F14, F124, F1234 is present on both of these lists. F1 has it and F4 has it. That is F1 intersection F4. That we can keep aside. We can add these 4 and equate it to these 4. So add these 4 equated to these 4, or 25 plus 22 plus 50 plus F13, which is this number, should be equal to 50 plus 24 plus 20 plus 45. This 50 gets knocked off. This is 47 plus F13 is 45 plus 44. 47 and F13 is 45 plus 44, or F13 is 42. Remember, this F13 only. This number is 42. Lovely. We've taken the fact that this is K and this is equal to K and plugged that in and got to 42. Super. We filled everything in. We've got a lot of detail. This is 42. Now what else is remaining? We found these 3, these 3, these 3, these three, these two. Just one piece here is missed out. We've used everything. We've used F1 is equal to F4. We've used F2 equal to 313. We used the idea these four are equal. All good, except for one fact, which is sum total of all of this put together is equal to 520. Plug that in, you should get this. Everything put together is 520. The whole thing put together is 520. We can think about this 520 in different ways. One is to add everything up, find the missing number and put it in, or go step by step. The approach we've taken is to say exactly 1, exactly 2, exactly 3, exactly 4. Exactly 4 is all 4. Exactly 1 is this, this, this and this. Those have been handed on a platter to us. Exactly 2, there are many terms, so we'll come to that later on. All 4 is this. Exactly 3 is these 4. And so if you take the 520, the total number, exactly 1 is these 4. 25 plus 30 plus 20 plus 26. 25 plus 30 is 55 plus 20 is 75 plus 26, 101. That is exactly 1. Exactly 3 is 200. All 4 together is 40. So add all of this, we get 341. And so from 520, if we subtract this 341, we'll get the remaining, just whatever, 179. That is 2 of these, exactly 2 of this, 1 and 3 only, or 1 and 4 only, etc., etc. There are 6 different terms there. 1 and 2, 1 and 3, 1 and 4, and then 2 and 3, 2 and 4, finally 3 and 4. Add all of this up, this is a missing term, equate everything, put together to 179, we are good to go, which is what we are doing here. So add everything up, 22 plus 42 plus F14 plus 26 plus 45 plus 24 is F14, F14 or F14. Remember, this has to be F14 with an underlining thing. It's only 1 and 4 is 20. This number is 20. With that, we have solved the entire grid. And so any combination of some 2 but not the other 2, some 3 but not the 4th, all 4 put together, none of the 4, all of those are there on a platter. You just need to jump to the question and answer them. What are the total number of schools having exactly 3 of the 4 facilities? 50, 50, 50, 50, 200. The kind of question where you solve the grid, then you're going to attempt the 4 questions in a hurry. What are the number of schools having facilities F2 and F4? F2 and F4 is some of these 4. Remember, it's not F2 and F4 only. It is F2 and F4. This entire intersection. 50 plus 50 is 100, 140, 185. Luckily that they are the choices. We're good to go. What are the number of schools having only facilities F1 and F3? Number 42. Number of schools having only facilities F1 and F4, the last number that we found, 20, good to go. Fine. Lovely set. Solving with 4 sets is tough, challenging. I did not do this in the exam, but I didn't even see this question. But it's a lovely set. I had quite some fun solving it. Drawing the diagram and solving is still possible. That's more intuitive. You get a feel for what the intersections are, but it's tricky. You need to be careful that when you draw circles like this, let's say we call this as F1, F2, F3 and F4. And so if you want to have F1, F2, F3, F4, F1 and F2 only is available here. F3 and F4 only is available here. F3 and F2 only. This is F3 and F2. F3 and F2 only. That becomes a very tricky region to map. On this diagram, you have to draw it slightly curved and take it out, or you have to say, I'm going to put all these regions, remember some of the missing regions, and store that data separately. And so there's other ways of depicting this, not exactly circles, but curved shapes. Sure, you can look that up. That is possible, but this framework is very useful. So do get some practice with this.
Students in a college are discussing 2 proposals. Proposal A proposal by authorities to introduce dress code on campus of the need of the hour. Just kidding. A proposal by the students to allow multinational food franchises to set up outlets on college campus. Glorious, glorious purpose. Wonderful proposals, all particularly important. A student does not necessarily support either of the two proposals. In an upcoming election for student union president, there are two candidates in fray, Sunita and Ragini. Every student prefers one of the two candidates. So wonderful, wonderful. I like where this is headed. There's a classification here. It's very important to get the hang of this. There is A and B, and then there is Sunita and Ragini. Right? But there's a very important distinction here. Between A and B, there are proposals. So I can imagine a student saying, hey, I'm for proposal A and for proposal B. And you can also imagine students saying, look, I'm not for either proposal. A student does not necessarily support either of the two proposals. So A and B, you've got to imagine it in our set theory framework. So people liking A, people liking B, that is A only, B only, both A and B, neither A nor B. Whereas Sunita and Ragini are two people who are contesting elections. And so you vote for one or you vote for the other. And so there's no, the sum total of Sunita and Ragini should be the total number of people who are sitting there. And so you don't have the luxury of saying I'll vote for Sunita and Ragini. You presumably don't have the luxury of saying there's none of the above option. You can't put nota and say, look, I don't like either of them. And so you are going to vote. Every student prefers one of the two candidates. And so that distinction, picking how this is classified and picking how this is classified, that's very crucial. A survey was conducted among the students by picking up a sample of 500 students. The following information was noted from the survey. 250 liked A, 250 liked B. Among the 200 who preferred Sunita as student union president, 80% supported A. Among those who preferred Ragini, 30% supported A. 20% of those who supported proposal B preferred Sunita, etc., etc., etc. So I'm getting the hang of this, but I'm going to stop reading this because I want a framework to put the data in. I want to fill in some table. Otherwise, I'm just reading all the constraints. So first thing in all of these DILR puzzles, you need to crack the idea of how am I going to capture this data. And clearly, there is a cross tabulation involved here. There is A and Sunita, B and Sunita, A and Ragini, B and Ragini. Fine. And then A and B sit inside a nice Venn diagram. And so we need to imagine the data to be sitting here in some kind of Venn diagram for A and B. So I would say how many people like proposal A, I would put that here. How many like proposal B, I'd put here. This is A only, B only, both A and B, neither A nor B, total number of people. A standard framework for capturing data. I'm not going to put Sunita Ragini like this because there's no Sunita and Ragini. There's no neither Sunita nor Ragini. Every student votes for one of the two. Right? So this I'm going to capture like that. The other one I'm going to capture like this. So Sunita, Ragini. So proposal A and Sunita, proposal B and Sunita, proposal A and Ragini, proposal B and Ragini. Remember, the total people on proposal A, I can add A and B, this will work. Right? For proposal B, you put C and D, you add these two, this will work. And so 40 people who like proposal B voted for Sunita and 90 people who like proposal B voted for Ragini. Then 40 plus 90, 130 have voted for proposal B. Because beyond Sunita and Ragini, there's no classification. Whereas this direction, it won't work like that. It's a crucial idea because you can say there are 100 people here and another 100 here. But the total could only be 160 because there's an overlap between these two and there's nothing outside of these two. Right? When you're capturing data, straight away remember that this part is nice and additive. That works. If 50 people from proposal A voted for Sunita, 70 people from proposal A voted for Ragini, then 50 plus 70, 120 is for proposal A. Everybody and anybody who voted for proposal A has voted for Sunita or Ragini and only one of them. There is no both Sunita and Ragini business. There is no neither Sunita nor Ragini business. Okay? Whereas that would be available, that would be present here. And so A plus C, there could be something here, there could be something here, 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 and the total could somewhat come out to be something very different. And to keep that in mind when you're capturing data, one of these data sets is in the set theory framework. The other one is in a nice table framework. And so keep that in mind because that distinction is going to be very crucial. Now let's go to the data points. 250 students supported proposal A, 250 support proposal B. Wonderful. 250, 250. Among the 200 students who preferred Sunita for union president, so 200 who preferred Sunita totally, 80% supported proposal A, 160. Immediately don't say 40 supported proposal B, not required. It could be 90, it could be 100, there could be an overlap here. Or it could be only 20, neither could be there. So that extrapolation we should not make. Keep that in mind. Right? But the total for proposal A is 250, total for proposal B is 250. So far so good. Among those who preferred Ragini, 30% supported proposal A. So Ragini, if total is X, then this is 0.3x, 30% of X. 20% of those who supported proposal B preferred Sunita. 250 is the total who's where for proposal B. 20% of that, 20% is 1/5. 1/5 of 250, this number is 50. Remember 160 plus 50 is 210. That only says that there's some overlap between A and B. That overlap is not 10 because there could be something in neither also. Fine, wonderful. We have plugged in the simple data points here. The first 4 data lines have gone in beautifully inside this. Think about this. Proposal A, 160 supported Sunita. Totally 250. So what will this number be? That will be the remaining. Or this 0.3x should be 90. We already discussed how this will be additive. Of the 250 in proposal A, some should have supported Sunita. The rest should have supported Ragini. There is no gap either way. Sunita plus Ragini must add up to 250. It cannot be lesser, it cannot be more. So this is 90. 0.3x is 90. X is, this is 0.3x. 90 by 0.3, which is 300. This is 90. What is this number? This is 250, this is 50. Same idea. This will be 200. Brilliant. 160 plus 90 is 250. 50 plus 200 is 250. All good so far. So we filled in a bunch of values. Let's capture all of them. Let's look at this. We've accounted for constraints 1, 2, 3, 4. It is 40% of those who did not support proposal B preferred Ragini. So this is did not support proposal B. This is outside number. 40% of those preferred Ragini. So that's going to be tricky. So not B. That will be A only and neither. It will be tricky because we don't know those data points. Right? Every student who preferred Sunita and proposal B also supported proposal A. This is interesting. Every student. So in Sunita, ones who supported proposal B also supported proposal A. Wonderful. So proposal B is a subset of proposal A. For Sunita, for candidates favoring Sunita, B is sitting inside A. Brilliant. So totally there are 200, of which this 50 sits inside this 160. So totally there will be 160, or neither this number is going to be 40. And among those who preferred Ragini, 20% did not support any of the proposals. 20% of 300 is neither. It did not support any of this. 20% of 300 is 60. 1/5. We can now get this in this. How so? We know our A union B formula. 90 and 200 are A and B. A union B is going to be 240. This is neither. We can nail that. Right? So now we put this 60 in. We know that in Sunita, B is sitting inside A, and we can find the outside number. Inside Ragini, we have 90 and 200 as A and B, and A union B to be 240. With that, we can find A intersection B. If we draw these two diagrams, we are through. Fine. So 160 here, 50 here, so outside should be 40. So neither should be 40. Both is 50 because B is sitting completely inside A. Here 90 plus 200 is 290 minus this should be 240. A union B is A plus B minus A intersection B. Number of elements. The cardinal number of A union B is A plus B minus A intersection B. 90 plus 200 is 290 minus whatever goes here should be 240. A union B is 240. Fine. So 240 equals 90 plus 200 minus A intersection B. 290 minus 50, or this should be 50. This will be 40. This will be 150. Both together should be 50. So out of this 250, 250, neither, people who like neither of these proposals, 40 plus 60, 100. People who like both of these proposals, 50 plus 50 is 100. Total number of people is 500. We filled out the entire grid. We know the whole thing. Now we can jump to the questions, and hopefully the question should be easy to solve. The most crucial thing here in this entire set is to recognize that for one of the data sets we are looking at a Venn diagram. For the other one we are looking at a table. For the one, when you're putting the whole thing on a table format, it is additive this way but not additive this way. If 160 people like proposal A and 50 like proposal B, then there are not totally 210 people, because there could be a bunch of people who like both, bunch of people who like neither. So to keep that idea open. But among people who like proposal A, if 160 vote for Sunita, 90 vote for Ragini, the totally 160 plus 90, 250. That once we crack that one thing, where we know that is either Sunita or Ragini, not both, not neither. Therefore, you can add in merrily. But it is not, if you're not voting for proposal A, that doesn't mean you voted for proposal B. You could have voted for neither. You cannot make that assumption. Once you're clear about that, then data captures becomes very simple. Let's look at questions. Among the students surveyed who supported proposal A, what percentage preferred Sunita for student union president? Among those who supported proposal A is 250. Among this, what percentage preferred Sunita? So out of 250, what percentage is 160? 16 by 25 into 100, or 64%. 100 by 25 is 4, 16 4, so 64%. What percentage of the students surveyed who did not support proposal A preferred Ragini as a student union president? Who did not support proposal A? Did not. That means proposal A 250 supported, did not support is 250. Right? That means we are leaving out this box. Right? Who did not support proposal A, sorry, not this part, did not support. So leaving out A, the remaining 250 we're keeping in mind. Wonderful. How many of these preferred Ragini as a student union president? So not A. Within that, how many supported Ragini? So not A would be 250. Within that, how many preferred Ragini? That will be this 150 and this 60. That is B only, and neither A nor B. Out of the 250 people who did not like proposal A, 150 liked proposal B and liked Ragini, 60 liked neither but liked Ragini, or totally 210 voted for Ragini, the remaining 250. This 90 is what we need to remove out of this 300. 300 people voted for Ragini. Within that, 90 supported proposal A. The remaining 210 did not support proposal A but preferred Ragini. So 210 were in the group of not proposal A but Ragini. So 210 out of 250 into 100 is what you're looking for. 21 by 25 into 100. This is 21 into 4, 84%. Wonderful question. What percentage of students surveyed who supported both proposals A and B preferred Sunita as a student? Both. Out of this 100, what percentage supported Sunita? 50 out of 100, half or 50%. This table gives everything we need. How many of the students surveyed supported proposal B, did not support proposal A, and preferred Ragini as student union president? They supported proposal B, but not A. Out of this 250, they liked B, but not A. That means this 50 we can ignore completely because that entire 50 is sitting inside. Only this 200 we are worried. Even in this 200, this 50 supported proposal A also. So this 150 is what we are looking for. This 150 is people who supported proposal B but did not support proposal A. So far so good. And preferred Ragini as student. The entire 150 prefers Ragini as student. Answer is 150. B but not A but also Ragini, or within this Ragini B but not A, which is 150. Delightful set. Nice and challenging. You should have picked this set only if you look at set theory and your eyes bulge out and say, okay, I like this territory. Otherwise, there are enough questions in this slot 2 paper which are solvable and are simpler than this. But if you like set theory or you like a hint of math sitting inside your puzzles, then you should jump at this. But otherwise, you can leave this and still find your marks from elsewhere. And second, it's a question from CAT 2018 DILR slot 1. And again, wonderful question based on set theory. Before we go further, straight away the caveat. Please look at this video if and only if you have tried this set. And you need to be very comfortable with the terminology, the terms, the jargon. This is not like watching a movie. So make sure you have spent time in trying this set out. You're familiar with the terms. And then jump in. Only then you can take value from this. Right? I'm going to jump in. Satellites. 1600 satellites were sent up by a country for several purposes. The purposes are broadcasting, communication, surveillance, and others. B, C, S, O. A satellite can serve multiple purposes. So it can be broadcasting and communication, communication and surveillance, surveillance and others, broadcasting, communication and surveillance. So this is a set theory question straight away. You're going to have some Venn diagrams and circles and all of that. However, a satellite serving either B or C or S does not serve O. So O is distinct from B, C, S. So imagine the Venn diagram. If you get this done in step 1, then you're through. If you don't get this done, then you're toast. And it's impossible if you don't get the right Venn diagram. I won't say impossible, but very difficult. This sentence right here gives you a killer Venn diagram. You've got to start with that Venn diagram. Otherwise, we are in jail. There is no overlap between B and O. There's no overlap between C and O. There's no overlap between S and O. Or think about this. The diagram should have B, C, S in some form and O separate. Brilliant. That's very important. The following facts are known about the satellites. The number of satellites serving B, C, and S, though may not be exclusively, are in the ratio 2:1:1. So looking at a diagram like this, this were B, C, S. The ratio is 2:1:1. O is separate. The number of satellites serving all three of B, C, and S is 100. This intersection here is 100. I'm going to draw this Venn diagram beautifully in the next couple of slides, but I'm just taking in the information. The number of satellites exclusively serving C is the same as the number of satellites exclusively serving S. And this number is 30% of the number of satellites exclusively serving B. We're talking about this number, and this number. The number of satellites serving O is the same as the number of satellites serving both C and S, but not B. Diagram is too complicated. I'm going to go to a bigger diagram and fill all this data and then look at the constraints. Right? After this, we are down to the questions. I don't think we have enough information to solve this grid and get all numbers. But there's just equal to, not equal to, and the ratio. There's only one number given. And so there's going to be some variable. I think my gut feel is we're not going to be able to completely plot out the grid. But let's fill it out any which way. This is how the diagram looks. This we are clear about. The total is 1600. And so we know that this number is 100. We know that this ratio is 2:1:1. Okay. And so we fill this. The number of satellites exclusively serving C is equal to the number of satellites exclusively serving S. These two are equal. There's 30% of the number of satellites exclusively serving B. So this is where Y, this is 0.3Y, this is 0.3Y. The number of satellites serving O is the same as the number of satellites serving both C and S, but not B. So this number, C and S but not B, is equal to this number. We put this as some K, this will also be K. Now the wonderful part here, there's the 100K and 0.3Y here, 100K and 0.3Y here. C and S are symmetric. The numbers are identical. The total is also same, or these two numbers should also be same. We can write this as X minus K minus 100 minus 0.3Y, which is what I'm going to call it as M. These two are equal. We know that M plus 0.3Y plus K plus 100 is X. And so we have X, K, Y, and M. Not 4 variables, only 3, because X and M are linked, or these are linked. There's one linkage which we already have. Okay. It doesn't look like we can solve this straight away, but we will get somewhere with some variables. And what can we get? We know that this set B is twice of this set C. And we know that the total is 1600. So let's use both of them. And so we know that Y plus 2M plus 100, Y plus M plus 100 is 2 times 100 plus M plus K plus 0.3Y. Wonderful. So Y plus 2M plus 100 is 200 plus 2M plus 2K plus 0.6Y. Luckily the 2M goes away. 100 comes this side, 200 minus 100 is 100. This 0.6Y can come this side. 0.4Y equals 100 plus 2K. There is something linking Y and K. So we know that 0.4Y is 100 plus 2K. Multiplying by 5 by 2 to get Y. Y equals 250 plus 5K. I'm taking this equation and multiplying by 5 by 2. I don't like the decimal 0.5. I don't want to deal with the decimal or a fraction when I'm writing an equation. So Y equals 250 plus 5K. Brilliant. This is one equation we've got. The other equation, add everything together. That is Y plus 0.3Y plus 0.3Y plus 2M plus 2K, M and M, K and K plus 100 equals 1600. And so, or we have 1.6Y plus 2M plus 2K plus 100 is 1600. 1.6Y plus 2M plus 2K is 1500. We know that Y is 250 plus 5K. So 1.6 into 250 plus 5K plus 2M plus 2K is 1500. 1.6 into 250 is 400 plus 8K plus 2K, 10K plus 2M is 1500, or 10K plus 2M is 1100, or 5K plus M is 550. We already know that 250 plus 5K equals Y. We know that 250 plus 5k equals y. We know 5k plus m equals 550. Fine, wonderful. So we can get a link between m and y also. We have a link between k and m, k and y, and m and y. So let's put these in. So I'm going to capture these two as equations. 250 plus 5k is y. 5k plus m is 550. Obviously, solving for k and m and y is not possible. And we know we have only two equations. That the number of elements in B is twice number of elements in C. And the total is 1600. We don't have anything else. And so we can write this maybe differently. We can say 5k is y minus 250 plus m equals 550. Or y plus m equals 800. So that's one other way of framing the same set of equations. Y and m add up to 800. And so another way of writing the same equation. Same two equations we are combining in a different way. But you haven't got anything more than this. And so we have not dealt with anything with x. And we know that with y, k and m, if you have one of these, we can have the other two. These three are linked. If you have y, you can find k. If you have y, you can find k, and with k, you can find m. If you have m, you can find k and then y. Any one, you can find the other two. If you're given one nugget, then everything else falls in place. When we have three variables and two equations, we can form only two equations. The grid cannot be completed. But if you have one nugget, then we are through. And now jump into the questions. What best can be said about the number of satellites serving C? Number of satellites serving C is m plus k plus 0.3y plus 100. So 0.3y can be written in terms of k. We know y is 250 plus 5k. So let's write this in terms of k. So m plus k, plus 0.3 into 250 plus 5k plus 100, which is m plus k plus 75 plus 1.5k plus 100. This is 175 and 2.5k. M plus 2.5k plus 175. Wonderful. But we have something linking m and k as well. M is 550 minus 5k. We can write that. So this is 550 minus 5k plus 2.5k plus 175. 550 plus 175, that is 650, 725. This is 725 minus 2.5k. This is what set C is. Wonderful. Now let's look at this. Obviously, the answer is not in terms of one value. And so we know the expression is 725 minus 2.5k. So the maximum this can be is 725. Must be between 400 and 800 is probably true, but not good enough. Cannot be more than 800. It's also probably true. Must be at least 100 is also probably true. Saying what best can be said. So let's try to find the minimum and maximum. The maximum C can take is 725 when k is 0. Can we put k as 0? If you put k as 0, y is 250, k as 0, m is 110. That is possible. Sorry, m is 550. Both are possible, nothing seems to be violated. Now, to find the minimum, then k should be maximum. Now think about this. 5k plus m is 550. If you put m as 0, k will be maximum. So k should be, k max is 110. So we could have 110 as k and y as 800. That is a possibility. So k max is 110. 2.5 into 110 is 275. So C minimum is 725 minus 275, which is 650, 450. Or the minimum value C can take is 450, maximum is 725. This is very appropriate. Remember, these are all true, but these are not the best that can be said about C. So don't just look at a choice, evaluate whether it is true or not, and mark the answer. This is the best description of the number of satellites serving C. What is the minimum possible number of satellites serving B exclusively? So we want to find minimum Y. We know that 250 plus 5K is Y. K can be 0. We've already seen that. If K is 0, then Y is minimum. Y minimum is 250. This will be 250. This will be 550. This will be 550. That is still a complete grid. That is possible. Minimum Y is 250. Exclusively serving B, 250. If at least 100 of the 1600 satellites were serving O, what can be said about the number of satellites serving S? We know K is greater than or equal to 100. Fine, that much we know. S, we've already found the expression for S because we found it for C. C and S are the same total number, 725 minus 2.5K. 725 minus 2.5K. We know that K is greater than or equal to 100. We know that K is less than or equal to 110. Is greater than or equal to 100. So K minimum is 100. K maximum is 110. 2.5 K min is 250. 2.5 K max is 275. If we put K as a minimum, then S will be maximum, or S maximum is 475. S minimum is 450. Wonderful. So now let's look at the statement. At least 475. Maximum is 475. Exactly 475. Not required. At most 475. This is true. The maximum possible value for S is 475. The number of satellites serving at least 2 among B, C and S is 1200. Which of the following must be false? For this you get a full information. At least 2 out of the 3, that is M plus K plus 100. 2M plus K plus 100 is 1200. 2M plus K is 1100. We know that 2M plus K is 1100. We know that 2M plus 10K is also 1100. This is this into 2. 2M plus K is 1100. 2M plus 10K is also 1100. Or K is 0. This is 0. This is 0. Which immediately gives us M is 550. $250 plus 5K is Y. Y should be 250. We've got everything. This should be 75. This should be 75. We've got a complete grid now. So which of the following must be false? All 1600 satellites serve B or C or S. This is true. This is 0. The number of satellites serving C cannot be uniquely determined. It can be uniquely determined because we have everything here. This must be false. The number of satellites serving B exclusively is exactly 250. True. The number of satellites serving B is more than 1000. 550 plus 550, 1100, 1200, 1450. Yeah, this is also true. Must be false is statement 2. We're going to talk about Fun Sports Club. So it's a wonderful question. As ever, if you have not tried this question, if you have not tried solving it, hit pause right now. Try this question, solve it through, try all variants, and then we'll come back and solve this. Fine. We'll come back and watch this. Fun Sports provides training in 3 sports: Gilli Danda, Kho-Kho, and Ludo. G, K, and L. Currently, it has an enrollment of 39 students, each of whom is enrolled in at least one of the 3 sports. Fine. Straight away, by the time you read this, you should be saying set theory, 3 sets, nothing outside. When it looks like that, we might change our opinion, but you should be jumping in and saying, okay, this is the kind of puzzle I'm getting into. And if you're naturally comfortable with set theory puzzle, you should just grab it and nail this. Fine. So you should know that template really well. The following details are known. The number of students enrolled only in L is double the number of students enrolled in all the 3 sports. Wonderful. So this reconfirms set theory. Only in L is double the number enrolled in all 3 sports. So if you say this is G, this is K, this is L, the total is 39. If this were X, this would be 2X. The total of 17 students in G. The number of students enrolled only in G is 1 less than the number of students enrolled only in L. This is 2X. This is 2X minus 1. The number of students enrolled only in K is equal to the number of students who are enrolled in both K and L. Both K and L is this put together. That is nothing but only in K. If this is Y, this will be Y minus X. The maximum student enrollment is in L. 10 students enrolled in G are also enrolled in at least one more sport. 10 students are enrolled in at least one more sport. At least one more sport is this region. That adds up to 10. And so we made some of these inferences and drawn this and scribbled this. I'm going to do this in a much more structured fashion by drawing the theory. Key thing in a lot of these puzzles, in set theory puzzles especially, is to not increase the number of variables, to have a clear idea of what the best starting point could be. So here we're going to focus completely on in which order should we approach the constraints. I love orders that are the constraints that are very specific, that involve actual numbers or details. Fine. If you're dealing with too much of one is twice the other, 4 more than the other, greater than this, minimum that, least possible, then all of those are constraints with a greater than, less than, and maximum, minimum thrown in. Whereas if you say Ram has scored 14, Shiva leaves at 4 p.m., Kishore stays in the greenhouse, that is specific. To gravitate towards the specific ones. Right? Jump in. One specific constraint in this list is this number of students enrolled is 17. That is obvious. The number of students enrolled only in G is 1 less than the number of students enrolled only in L. So if this were X, this will be X minus 1. And so P minus 1. 10 students enrolled in G are also enrolled in at least one more sport. So that means this number, all these put together, adds up to 10. What does that give us? There are 3 different regions here, but we don't have to worry about those 3. Those 3 add up to 10. What we know is this remaining is 7. This is 7. It should be 8. Fine. So this being 7, this being 8 is a big giveaway. This is 7. This is 8. Fine. Now let's see what else is clear. The number of students enrolled only in L is double the number of students enrolled in all 3 sports. Only in L is 8. This is double of this. This should be 4. These 2 add up to 10. Sorry, these 3 add up to 10. So this plus this should add up to 6. That much we know. And now let us look at the other constraint. The maximum student enrollment is in L. Then let's see which one is the next one to open up. The 10 students enrolled in G are also enrolled in at least one more sport. This plus 4 plus this should be 10, or these 2 add up to 6. We call this as X. This will be 6 minus X. Right? So now we get some more clarity. 7X, 6 minus X, 4. These 3 add up to 10. This is 8. Now let's look at the next constraint. The number of students enrolled only in K is equal to the number of students who are enrolled in both K and L. So if we put this number as say Y, this will be Y minus 4. these two, y minus 4 plus 4 adds up to y. These two put together should be equal to y. So this is y, this is 4, this should be y minus 4. With this, we can possibly figure out one of x or y, because we know that the total is 39. And the total is 39. 7 plus 10, 17 plus 8, 25 plus 2y minus 4. 25 plus 2y minus 4 is 39. Or 2y is 39 minus 21, which is 18, or y is 9. How did we get 25? 7 plus 10, 17 plus 8, 25 plus y minus 4 plus y is 39, or y is 9. This is 9 and this is 5. Fine. Wonderful. We've got this far. We filled in every number possible. We have only one constraint that we have not accounted for, which is the maximum student enrollment is in L. Right? So number of students enrolled in L, 8 plus 5, 13, 13 plus 4, 17 plus 6, 23, 23 minus x. Enrolled in K is 9 plus 5, 14, 14 plus 4, 18, 18 plus x. And G is 17. Now 23 minus x should be greater than 17. 23 minus x should be greater than 18 plus x. Obviously, this is a better constraint because x cannot be negative. So 18 plus x is more than 17 any which way. So let's plug in that constraint and get some value going for x. And so we know that 23 minus x is greater than 18 plus x. 23 minus 18 is greater than x plus x. 2x is less than 5. X is less than 5 by 2. 5 by 2 is 2.5. We're looking for integer values of x. X could be 2, 1, or 0. Maybe there'll be some constraint which says it cannot be 0, but right now we'll account for 0 also. X can be 2, 1, or 0. Everything else we know, and we also know that x could be 0, 1, or 2. Keep that in mind. Now, beyond this, we cannot go with a set of constraints given. We filled quite a few numbers, and we have 2 open cells with 3 possibilities totally. Now let's jump in and solve these questions. What is the minimum number of students enrolled in both G and L but not in K? In G and L but not in K, we want minimum of 6 minus x. X can take values only 0, 1, or 2. If x were 2, this would be small. So 6 minus 2 is 4. Minimum value of G minus x is 4. That's what we're looking for. And once you've got the entire set theory diagram built in, then this question becomes far simpler. The number of students enrolled in K and L are in the ratio 19:22. 19:22. Then what is the number of students enrolled in L? 19:22. L has 23 minus x. K has 18 plus x. This ratio is 19:22, or x equal to 1. Number of students registered in L. L is 23 minus x, 22. Done. We needn't have done any of this. The ratio 19:22. We're talking about integers. It could only be 22. Nothing else is possible. Due to academic pressure, students who were enrolled in all 3 sports were asked to withdraw from one of the 3 sports. After the withdrawal, the number of students enrolled in G was 6 less than the number of students enrolled in L, while the number of students enrolled in K went down by 1. So all 3, these are distributed away. They're asked to deregister for one course or remove their names from one course. They're supposed to withdraw themselves. These 4 are going to get distributed across this, this, and this. The number for K drops by 1, or one of the students withdraws from K. That means one student goes here. From 4, 1 goes here. The other 3 need to go here and here. So if 1 goes here, this is going to become 7 minus x. Right? Now we don't know how many go here and what go here. Totally 3 disappear here. And so this number, this should, if you can account for one other variable, if you say m students come here, then 3 minus m students go here. Totally 3 students go away from here into here. So let's rejig this diagram. Bang in the middle is 0. This becomes 7 minus x. So 1 has gone here. Some m go here. Some 3 minus m go here. Fine, brilliant. So 3 plus x minus m is this region. This is 0. 7 minus x, 5 plus m, etc., etc., etc. Now we know we've accounted for the idea that the number of students enrolled in K went down by 1. We have not accounted for the idea that number of students enrolled in G was 6 less than the number enrolled in L. G is 7, 14 minus x plus 3, 17 plus x minus x and plus x get cancelled. G would be 17 minus m. The total number of students in G would be 17 minus m. Number of students in L would be 8 plus 7, 15 plus 5, 20. 20 plus m minus x. The difference is 6. Obviously, the number of students in L is higher. So 20 plus m minus x minus 17 minus m is 6. This is 3 plus 2m minus x is 6, or 2m equals x plus 3. Minus x comes this side, becomes x. 6 minus 3 is 3. 2m is an even number. X plus 3 should be an even number. We know x can take only values 0, 1 and 2. So x has to be 1. Only 1 plus 3 is an even number in this category, in this set. Or x is 1, which makes m to be equal to 2. How many students were enrolled in both G and K? G and K is 3 plus x minus m. 3 plus 1 minus 2. 4 minus 2, 2. Due to academic pressures, students who are enrolled in all 3 sports were asked to withdraw from 1. The number in K dropped by 1. L is greater than G by 6. It's exactly the same text. How many students were enrolled in both G and L? G and L is 7 minus x. We know that x is 1. 7 minus x is 7 minus 1, which is 6. Wonderful set. If you're comfortable with set theory, you should be jumping at this set. It should be very doable. So you should know the chance of finding one set theory puzzle out of 8 is very high. So if you do a bunch of questions, then you know whether you're at home with that type of question. If you are, you should jump in, nail that, and then carry on from there. Very interesting set. Have a run through this. So the description is given in 3 different slides. As ever, I'm going to take some time off for you to read and take this in, and then we'll do this later on. It's a fabulous set. It looks like it's a very logical reasoning set, but it's more than plain vanilla logical reasoning. There's a little bit of sets that come in, there's a bit of numbers that come in. The wonderful set and the wonderfully tough set. So read this. We'll discuss this in detail. Don't worry if you're seeing a plain screen with that window without volume. I'm just giving some time for you to read this set. I've moved on to slide 2 so that you get the data in this set as well. I'm going to move on and give you a sneak peek at
third slide as well. It's a fabulous set. It takes a while to just digest the data points and get a sense of how what is going to be. The entire data set here is given in detail on our Facebook event page, which is mentioned in the description of this YouTube video. So watching slide by slide, reading slide by slide is a bit of a pain, as it can be. You just click on that link, go onto the Facebook page, sign in, have a read through all the data in one go. And so it's tough to do a DILR session on just YouTube with a shared screen, because I might be doing it in one sequence, but you might be looking at data slightly differently. I might want to look at slide 1 again. You might want to read this and then want to recap something here. And all of that happens. This format becomes tricky. Which is why I'm a gigantic fan of not just doing live sessions, but actually learning on a learning platform where you can see everything, try it out on your own, then move on to the solution. Otherwise, we have too much wasted time here and there, right? But we'll make do with what we have. YouTube is a fabulous platform that gives us this much. So let's not whine about the last 2 bits we're leaving on the table. This is what is present in slide 2. This is present in slide 3. I'm going to give 1 more minute to just read all the data points, and then I'm going to read it slowly and construct it list. I also checked, and the 4th wicket has fallen, and India are more than 100 runs away. So Virat Kohli is still there. Hopefully, he'll be there at the end of the session as well. Well, I'm going to read this. Applicants for the doctoral programs of Ambi Institute of Engineering and Bambi Institute of Engineering have to appear for a common entrance test. The test has 3 sections: physics, chemistry, and math. Among those appearing for CET, those at or above the 80th percentile in at least 2 sections and at or above the 90th percentile overall are selected for advanced entrance test conducted by AEE. AET is used by AIE for final selection. So this is initial selection. You get 90 overall, and above 18 at least 2. And remember, above 18 at least 2, not in everything. For the 200 candidates who are at or above the 90th percentile overall, based on CET, the following are known about their performance in CET. So this 200, some subset of this is going to qualify for AET. Remember that. For AET, the constraint is you should get 90th overall and at least 80th in 2 out of the 3. And at least 2 out of the 3. Fine. So some subset of this 200, some fraction of this 200 is going to qualify to write the AET. No one is below the 80th percentile in all 3 sections. Straight away, by this time, you should have said, oh my God, this is one of those sets. One of which sets? One of those sets where we're going to draw something like this. 200 overall, 0 here. You should be on that track by the time you read this. If you're not on that track and you're going to write a series of constraints and equations, you've not sensed Venn diagram yet, then you're in trouble. Then you need to go revisit set theory and logical reasoning, do lots of questions where this language comes into play. Being given a physics, chemistry, and math, you're told at least 2. So you're going to have A intersection B, B intersection C. You're going to speak that language. Right? So remember that. So let's look at this. No one is below the 80th percentile in all 3 sections. That's good. 150 are at or above the 80th percentile in exactly 2 sections. Exactly 2 sections. That is this region, and this region. Those 3 add up to exactly 150. The number of candidates at or above the 80th percentile only in P is the same as the number of candidates at or above the 80th percentile only in C. Same as the number of candidates at or above the 80th percentile only in M. Fabulous. This simplifies life enormously. Seems to be a very easy question. PCM. This number, and this number are all same. The other 3 add up to 150. These 3 are equal. Outside is 0. This seems like a very easy question. Hang on. That's not what I said before. It's actually an incredibly tough question. It just looks like a lot of data points have been filled. But but what is not filled is instructive. Right? Let's look at the last nugget as well. The number of candidates below 80th percentile in P is to number of candidates below 80th percentile in C is to number of candidates below 80th percentile in M is 4:2:1. And below 80th percentile, that is P dash, not in P, outside of P. So outside of C, outside of M, ratio is 4:2:1. Till here, I was very happy. I think some things add up to 150, some three things are equal, some one number is 0. I liked all of those. Here I have a ratio, not just two things, but three things. So, and this is P dash. P complement is to C complement is to M complement is 4:2:1. I already know it's one of those constraints with a lot of variables that are coming in. It's a pain. I know that I'm going to have to figure out a bunch of things starting there. Look at the next one. Still not done with the question. BIE uses a different process for selection. If any candidate is appearing in the AET by AIE, BIE considers their AET score for final selection, provided the candidate is at or above the 80th percentile in P. Incredibly complicated. BIE takes AET score if the student is appearing in AET, assuming that the student has scored more than 80th percentile in P. So I presume BIE is a physics-based institute. Basically saying if you're qualified for the AET, you're good enough, and you've got 80th percentile in P, you're good enough in physics, then you do not need to take another exam that I'm providing. I'll just take that score and you're through. Any other candidate at or above the 80th percentile in P in CET, but who's not eligible for the AET, is required to appear in a separate test to be conducted by BIE for being considered for final selection. Altogether, there are 400 candidates this year who are at or above the 80th percentile in P. Super, wonderful. There are 400 candidates who are at or above the 80th percentile in P. All of them are going to be eligible for BIE. Some of them are going to be selected based on the AET. So few of them who've got 80th percentile in P and at least 80 in at least two of the three and at least 90 overall would have automatically written the AET. So we take their score. The remaining who don't tick all these boxes but have got more than 80th percentile in P, we have to write this BIE exam. And so one set of criteria greater than 80 in P, yes, no. No, you're out. If it is yes, then the next set of criteria, eligible for AET also. Yes, then your AET score counts. No, then you write some BET score, a separate test conducted by BIE. That's how the algorithm is. But BIE is a physics-centric institute. That's what we can infer. So 80th percentile in physics is mandatory. If you've got that and also happen to satisfy a bunch of other conditions required for AET, then you are BET, BIE plus physics plus. So it's okay. So you have other things also going for you. Good. So we'll take your AET score. But if those other things are not satisfied, therefore you're not writing your AET, but you've got more than 80th percentile in physics, we'll still take you on board after writing an alternate test. Wonderful. A bunch of questions here. Critical thing here, this seems to be a lot of information. So here, unlike the previous question, I think we'll have to end up solving quite a bit with the existing constraints and figure stuff out based on the existing constraints. And then we'll go to the questions. The questions could be useful, could be instructive. There could be some catches, caveats in the question, but I think there is something to do with the stem here. So, I'll draw the diagram. Greater than 90th percentile overall is 200. No one is below the 80th percentile in all three. That is 0. This is 0. Total is 200. X, Y, Z. These three add up to 150. Done all this. Wonderful. So bang in the middle, let us call this as K. That's also wonderful. So no one is below 80th percentile in all three. This we have incorporated. This we have incorporated. Let's build on this. These three are equal. We've already seen that A. Wonderful. And so this plus this is 150. So 3A plus K is 50. So we don't have that many variables. This K is linked to this A. That's useful. So we got that far. That's super. So now comes the trickiest part. We've incorporated the first simple constraint. Outside is 0. All three are A. X plus Y plus Z is 150. That we have done. Now we come to the P complement part. It's a tricky part. Right? What is not in P below 80th percentile would be A plus X plus A. Thankfully, this is 0. A plus X plus A. Not in C is A plus Z plus A. Not in M is A plus Y plus A. Whereas below 80th percentile in P is 2A plus X. Below 80th percentile in C is 2A plus Z. Below 80th percentile in M is 2A plus Y. Now comes a tricky part, wonderful part. This ratio is 4 is to 2 is to 1. We multiply this by 4 and this by 2 and this by 1. All three should be equal. This is 4 times of this. This is 2 times of this. This is 2x of this. And so, fabulous. And so, now it looks like we can solve this and go somewhere with this. But remember, 4 is to 2 is to 1. Actually, two equations. 4 is to 2, 2 is to 1. If you write those two equations, the 4 is to 1 equation will be a derivative of this. The two independent ratios that are given here, not 3. X plus Y plus Z is 150. That is one equation. But we have an X, Y, Z, and A. K is not a new variable. K and A are linked. You get one, you get the other. We have X, Y, Z, and A. And we have two equations with this ratio and one equation with the idea that X plus Y plus Z is 150. So we can manipulate this for quite a while, but we're going to probably struggle to solve 3 equations in 4 variables, X, Y, Z, and A. And the equations are complicated enough with a lot of ratios. And this is where I really struggled when I solved this question for the first time. I wrote P dash is 2 times C dash, formed an equation. C dash is 2 times M dash, solved it, formed an equation. Tried to incorporate that into X plus Y plus Z equal to 150. Tried to get all kinds of ratios. I went mad, went berserk. And so the key takeaway from all my travails there is anytime you get a question with multiple ratios like this, 4 is to 2 is to 1, 3 is to 11 is to 14, 7 is to 19 is to 37. 3 ratios like this. Use them extensively. How do I use them? I'm going to call 2A plus X as 4M, 2A plus Z as 2M, 2A plus Y as. And so this is very useful. So now I can reframe X, Z, and Y in terms of M. I can say X is 4M minus 2A. Z is 2M minus 2A. And Y is M minus 2A. So I'm calling X, Y, and Z in terms of a single variable, making life simple for myself. We're given a big ratio. Skip that ratio. Very often that ratio is a wonderful starting point for your variables. Important idea. If you told A is to B is to C is 4 is to 7 is to 11, call them 4K, 7K, 11K, and then work out the other bits. Second point here, we know that A plus A plus A plus K is 150. 3A plus K is 150. All of these are positive. 3A plus K is 50, not 150, sorry, 50. And 3A plus K is 50. A plus A plus A plus K is 50. Or A is less than or equal to 60. It could be even 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way till 60. Only that many values are possible for this A. And remember this, because sometimes being street smart and framing the question differently is very useful. I'm going to work on that. And so we discussed this. 2A plus X is 4M, 2A plus Z is 2M, 2A plus Y is M. I know that this x plus y plus z is 150. Somewhere I want to use that. That's a bazooka. So I'm going to say, how do I use that? If I add these three equations, I'm going to carve out an x plus y plus z. Fabulous. So I'm going to add those three equations. So 2a plus x plus 2a plus z plus 2a plus y. 6a plus x plus y plus z, 7m. Wonderful. This is a fabulous equation because now I'm dealing only with two variables. X plus y plus z is 150. Or we know that 150 plus 6a is 7m. 150 plus 6a equals 7m. We are home and dry. Using just this, we can figure out everything else in this question. 150 plus 6a is 7m. Remember, a could be 0, 1, 2, 3, 4, 5, 6, all the way to 16. A is a whole number. A cannot be negative. A cannot be 17 or more. Okay. I'm going to do a bit of trial and error. So think about this. Let's say A is 0. 150 equals 7m. Doesn't work. A is 1. 156 equals 7m. Is 156 a multiple of 7? 140 is a multiple of 7. 154 is a multiple of 7. 156 is not a multiple of 7. A equal to 2. 162, not a multiple of 7. Let's go step by step from here and try to locate a multiple of 7. Fabulous idea. Think about it. The numbers I have are 150, 156, 162, 168, 174, 180, 186, 192, 198, 204, 210, 216, 222, 228, and so on. They're not a multiple of 7. 154 is a multiple of 7. 161 is a multiple of 7. We have a winner. 168 is a multiple of 7. Fabulous. Or if I have 150 plus 6a equals 168, I'm through. 150 plus 6 into 3 is 7 into 24. That's a possibility. And then I keep on adding multiples of 6. I need to get a multiple of 7. This works. The next step that will work will only be 150 plus 6 into 10. I need to add a multiple of 7 here. So if 6 into 3 works, the next step should be 6 into 10. I'm adding 7 more 6s. That will account for 6 more 7s. 150 plus 60 equals 210. 150 plus 6 into 17 will be equal to 7 into 36, but this is not possible. Or I have two possible values. Or A could be 3 or A could be 10. If A were 3, then M would be 24. If A were 10, then M would be 30. Either I have 3 and 24 or 10 and 30. I'm going to plug in 3. I mean, this is 3, this is 3, this is 3. The remaining would be 41. Wonderful. I have x plus 2a is 4m, or x plus 2a, I'm going to write down somewhere here, x plus 6 is 4m, or 96, 24 into 4, or x is 90 here. Z plus 2a is 2m, or z is 2m minus 2a, which is 48 minus 6, 42. Y is m minus 2a, 24 minus 6, which is 18. So not P, less than 80th percentile in P is 96. Less than 80th percentile in C is 48. Less than 80th percentile in M, so leaving this out, is 24. 4 is to 2 is to 1. That ratio works perfectly. And all the numbers, these 4 numbers add up to 50. Everything put together adds up to 200. These three add up to 150. Got this completely done. Other possibility is that A could be 10. So this is 10, this is 10, this is 10, 30 gone, this should be 20. That works fine. After that, we know that x plus 2a is 4m, m is 30, x plus 20 is 120, or x is 100. That goes here. We have z plus 2a equals 2m, z plus 20 equals 60, z is 40. Y plus 2a equals m, y equals 30 minus 20, which is 10. These three add up to 50. The overall numbers are p dash is 120, c dash is 60, m dash is 30. 120 is to 60 is to 30 is 4 is 2 is to 1. That works. All numbers put together add up to 200. That works. The P only, C only, M only are 10, 10, 10. That works. All three are equal. So fabulous. So we have two possibilities now, 3 or 10 for P only, C only, and M only. And then for each of those combinations, you have multiple sets of answers. So remember, this started off as a fabulous logical reasoning puzzle, became a Venn diagram question, then went on to become a ratios question, finally became a number theory question. The whole crux of solving this is 150 plus 6a equals 7m. So be street smart. Anytime, what the takeaways from here, anytime you're given a ratio based thing, start with your variables with a ratio based thing. Anytime you have lots of variables and maybe more than one solution, don't go down the algebraic route, go down the street smart route. You know that a cannot take any value. A can only be from 0 to 16, and m can also correspondingly be only set of values based on what a can be. So try to solve and try different possibilities rather than algebraically framing equations and solving that. The cat has cranked up the level of difficulty. Multiple solutions are possible. They want us to think about set theory, Venn diagram, ratios, and number systems at the same time. We're effectively solving for 150 plus 6a equal to 7m. So be street smart about this. Now let's go to the questions. What best can be concluded about the number of candidates sitting for the separate test for BIE who were at or above the 90th percentile overall in CET? At or above 90th percentile in CET. In this category, the only guys who will write BIE are the ones who got above 80th percentile in P, but not in one more beyond P. They got more than 80th percentile in two of the three, then they'll write AET. They're not writing AET. They're writing the separate exam for BIE. They should have got above 80th percentile in P, but not in C or M. Effectively, this question is saying, give me the number sitting inside P only in your Venn diagrams. P only could be 3, P only could be 10. Very simple question, but incredibly trickily worded. You're saying, among all your guys with greater than 90th percentile, which ones have to write the BET exam, the other test conducted by BIE? For writing BIE, you should have got more than 80th percentile in P. So I'm looking at only P, but you should not have written AET. AET you will end up writing if you've got more than 90th percentile overall and more than 80 in at least two of the three. So if you've got P and C and P and M, or P, C and M, you've written AET anyway. So you're looking for P only in this bunch, that is 3 or 10. Wonderful question because the way it is worded. The number of candidates who are at or above the 90th percentile overall and also at or above the 80th percentile in all three sections in CET is a multiple of 5. What are the number of candidates who are at or above the 90th percentile overall and at or above the 80th percentile in both P and M in CET? Basically, he's saying the number in between this number a multiple of 5. All 3 is a multiple of 5. All 3 could be either 41 or 20. It is not 41, it's only 20. So effectively, all this cuff is to select this Venn diagram and not the other one. Now let's look at the question. What are the number of candidates who are at or above the 90th percentile overall, effectively within this Venn diagram, and at or above the 80th percentile in P and M? P and M. P and M would be this 40 and this 20. This P, M and C. That's all right. P and M, I'll have to count both. 40 plus 20, 60. It's a theta question. Don't end up writing 40. They're not saying only P and M. They're saying P and M. So it could be PM, PM and C. Guys who have got above 80th percentile in all 3 have definitely got above 80th percentile in P and M. That is included. So 40 plus 20, 60. If the number of candidates who are at or above the 90th percentile overall and also at or above the 80th percentile in all 3 sections in CET is actually a multiple of 5. Once again, he's taken us to that Venn diagram where the middle number is 20. Then how many candidates were shortlisted for the AET by AIE? AET for AIE, not for BIE, for AIE. AIE condition is more than 90th percentile overall and at least 2 of the 3. So in this diagram, we'll count this, 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 and this. So 150 plus 20, 170 get shortlisted to write the AET. These 10, 10, 10 cannot write the AET because they have not satisfied the second criteria, which you should have got at least more than 80th percentile in at least 2 of the 3, P, C, and M. Go to the last question. The number of candidates who are at or above the 90th percentile overall and also are at or above the 80th percentile in P in CET is more than 100. How many candidates had to sit separate test for BE? Above 90th percentile overall and above the 80th percentile in P is more than 100. So this we are selecting from 2 Venn diagrams. So we're looking at either this one or this one. So if it were this diagram, then you're dealing with 40 plus 20 plus 10 plus 10. It adds up to only 80. In this case, it will be 42 plus 41 plus 18 plus 3. 21, 62, 104. So effectively, we are being told if the situation were like this. The initial conditions for all of these questions are basically saying, are you selecting the 3 Walla Venn diagram or the 10 Walla Venn diagram? That's it. There are 2 possibilities. Each of those questions basically says which of the 2 is relevant for that question. So you take the stem and carve out both Venn diagrams. And each question says, okay, this time we look at the 3 Walla diagram, this time we look at the 10 Walla diagram. That's all there is to this. Okay? Now let's look at the question. It's more than 100. So effectively we are dealing with this. How many candidates had to sit for the separate test for BIE? So let's do this. Among the guys who had got this, who had taken AET would be this, this, and this. This 3 cannot have taken the AET. So 18 plus 41 plus 42 are eligible for BIE, and within this sum, all of them would have taken the AET. So 2 plus 1, 3, 11, 1, 1, 2, 6, 10. 101 guys have taken the AET. There are 400 guys who are eligible for BIE based on the fact that they've got more than 80th percentile in P. Of these, some could have just taken and tried for BIE through the AET, which is 101. The remaining who have qualified based on their physics, but have not got all these other things in order to write the AET, have to write the separate test for BIE. Or out of the 400 who have qualified, 101 write an attempt to get in through the AET. The remaining 299 have to write the separate test. And so absolutely awesome set of questions. I made like multiple sets of mistakes trying to crack this. Right, so I had a long, difficult task trying to solve this. I spent a long time, made a bunch of mistakes. I've learned a lot in trying to just solve this question. I'm going to capture all the things that I learned. Don't underestimate this exam. We're effectively saying we can take a question, make it sound innocuous like to enter the exams, and then add a layer of Venn diagram to it, add a layer of ratios on top of that, 4 is to 2 is to 1, and then add a layer of number systems on top of that, end up with 2 solutions, and then carve out questions after that. So don't underestimate this exam. I think I did that, and then I struggled. Second thing, if you're given a ratio 4 is to 2 is to 1, then that very frequently that ratio part becomes the best part to start. Something is 4 is to 2 is to 1. Start off by saying, I'm going to assume the numbers as 4m, 2m, m, and then reshape your rest of the equations from there. Don't deal with an x by y is 4 is to 2, y by z is 2 is to 1, x by z is 4 is to 1. Don't do that. You're dealing with 3 variables. Some 3 things are in the ratio 4 is to 2 is to 1, 4m, 2m, m. And then shape the remaining from this. It's a very useful idea. And if you're given a constraint and multiple solutions are possible, then your street smart number systems based idea is probably going to work better than saying I'm going to solve this algebraically and frame different equations. So, wonderful set of questions.